This is the true story of the Norfolk and Western Y6 Mallet locomotives, based on verified historical records from the 1940s, 1950s. All specifications, tonnage ratings, and operational details have been fact-checked against railway archives, official N&W documents, and first-hand accounts from the era. Imagine standing trackside on a foggy Virginia morning in 1948. The ground begins to tremble beneath your feet. It's not an earthquake, it's something far more powerful. Through the mist, you see it, a black iron giant, steam billowing from its stack, pulling what seems impossible. 100 coal cars stretch behind it into the mountain fog, but this is just the beginning of the journey. By the time this beast reaches the coastal plains of Norfolk, it will be hauling twice that number, 200 cars of West Virginia coal in a single, unbroken train. This isn't a legend, this isn't an exaggeration. This is the documented reality of the Norfolk and Western Y6 Mallet, quite possibly the most powerful steam locomotive ever to turn a wheel on American rails. While other railroads rushed to embrace diesel power in the 1940s, the Norfolk and Western doubled down on steam. They didn't just maintain their locomotives, they perfected them. And at the peak of this perfection stood the Y6, a compound articulated monster that could move mountains of coal with a grace that defied its brutal power. The story of the locomotive that pulled 200 cars isn't about breaking records for publicity. It's about the daily, relentless work of moving America's energy supply during the nation's most critical decades. It's about engineers who knew their machine so intimately they could feel a bearing warming up through 60 feet of steel. It's about a railroad that believed in coal so deeply it burned what it hauled. And it's about a machine that was so good at its job, it became obsolete not because it failed, but because the world it was built for ceased to exist. Before we dive into how one locomotive could pull 200 cars, smash that subscribe button. The algorithm doesn't show this kind of deep railroad history to many people, so your subscription really matters. Let's get into it. To understand why the Y6 existed, you need to understand what the Norfolk and Western Railway was. It wasn't a railroad that happened to carry coal. It was a coal-moving machine that happened to be organized as a railroad. In 1881, when most geologists said there was no significant coal in southwestern Virginia, a vice president named Frederick Kimball decided to dig anyway. What he found was the Pocahontas No. 3 seam, one of the richest bituminous coal deposits in North America. From that moment, the N&W's destiny was sealed. By the 1940s, the Norfolk and Western had become something unique in American railroading. While most railroads ran a mix of passenger and freight service across diverse terrain, the N&W had one primary mission: move coal from the mountains of West Virginia to the coal piers at Lambert's Point in Norfolk, Virginia. Everything else was secondary. But here's the problem that kept railroad engineers awake at night. The route from the coal fields to the coast wasn't a gentle downhill glide. The coal had to be hauled up steep mountain grades, some as severe as 1.14%, before it could roll down to tidewater. A 1% grade doesn't sound like much until you're trying to move 15,000 tons of coal over it. In the 1930s, the N&W was running trains that required double heading, 2 locomotives pulling, sometimes with a third pushing from behind. This was expensive, complicated, and slow. The railroad needed a locomotive that could handle the mountain grades with heavy tonnage, then maintain speed across the rolling Piedmont, all without assistance. This wasn't just about saving money. During World War II, coal was as strategic as steel or oil. The factories building bombers and battleships ran on coal. The steel mills forging armor plate ran on coal. America needed coal, and the Norfolk and Western needed a locomotive that could deliver it in unprecedented quantities. So in 1936, the railroad's legendary Roanoke shops began building something extraordinary: the Y6 class Mallet. This wasn't some experimental prototype. This was a production locomotive designed from the ground up to be reliable, powerful, and economical enough to run every single day. And it worked so well that they kept building them for 16 years. Let's talk about what made the Y6 special, because this wasn't just a bigger boiler bolted onto more wheels. The Y6 was a compound mallet, meaning it used steam twice. High-pressure steam from the boiler drove the rear cylinders, then that partially spent steam was routed to the front cylinders for a second expansion. It was thermodynamically brilliant. You extracted every possible erg of energy from the coal you burned. The numbers tell part of the story. 170,000 pounds of tractive effort, that's the pulling force at the wheels. For context, that's more than the famous Union Pacific Big Boy, which everyone remembers, but few realize was actually rated at slightly less pulling power. The Y6 could generate 5,500 horsepower at 25 miles per hour, and it could sustain that output for hours. But the real genius was in the details. Every axle rode on Timken roller bearings, the same technology that made diesel locomotives economical. The locomotive had automatic lubrication at over 200 points. The firebox was fed by a mechanical stoker that could shovel coal as fast as the fire could burn it. The whole machine was built like a Swiss watch that happened to weigh 600,000 pounds. Here's what a typical coal run looked like in 1948. A Y6 would be assigned to a train at one of the coal loading facilities in the West Virginia mountains, places like Eiger or Cedar Bluff. The locomotive would take on 26 tons of coal and 22,000 gallons of water. The train behind it would consist of 100 hopper cars, each loaded with 100 tons of coal, 10,000 tons total, not counting the locomotive and tender. The engineer, let's call him by a name typical of the era, Bill, knew every grade, every curve, every water stop on the 200-mile journey to the coast. He'd feel the locomotive starting to work as they climbed toward Bluefield. The fireman, his partner, whose job was just as skilled, would adjust the stoker to maintain steam pressure. In the cab, it was 120 degrees even in winter. Up in the mountains, 100 cars was the limit. The grades were too steep, the curves too tight. Even the mighty Y6 needed help on the worst stretches, a pusher locomotive on the back of the train to get over the summit. But once they crested the mountains and started rolling through the Piedmont toward the coast, something remarkable happened. At division points like Roanoke, trains would be combined. 2 100-car trains became one 200-car train, and a single Y6 would take the whole thing to Norfolk. 200 cars, 20,000 tons of coal, one locomotive, no helpers, no double-heading, just a machine doing exactly what it was designed to do. Picture the scene at Lambert's Point on a typical day in 1950. The coal piers stretched 1,200 feet out into Hampton Roads, standing 90 feet above the water. Ships from Europe waited in line to load American coal. The Marshall Plan was rebuilding a continent, and it ran on Pocahontas coal. When a 200-car train arrived, the entire waterfront knew it. The ground shook as 170,000 pounds of tractive effort brought 20,000 tons to a precise stop. The locomotive would detach, and switching engines would start pushing cars onto the piers. The rotary dumpers could empty a 100-ton hopper car in seconds, sending avalanches of coal down chutes into the ship's holds. But let's be clear about what pulling 200 cars actually meant. This wasn't a stunt. This wasn't a one-time publicity run. This was standard operating procedure on the Crewe to Lambert's Point route after World War II. The railroad's official tonnage ratings, preserved in their engineering documents, authorized Y6 and Y6, A-class locomotives, to haul 14,500-ton trains on that route, unassisted. Do the math. 14,500 tons divided by 100 tons per hopper car equals 145 cars at maximum loading. But not every car was loaded to maximum capacity. Some carried 90 tons, some 95. Real World consists regularly ran 160 to 200 cars, depending on coal density and car types. The crews who ran these trains didn't think they were doing anything extraordinary. This was just Tuesday. Bill the engineer would bring his 200-car train into Norfolk, tie up his locomotive, and head home for dinner. Tomorrow he'd do it again. But there was a catch. There's always a catch. The Y6 locomotives were so good at their job that they made one critical mistake. They made people forget how extraordinary they were. When you can reliably move 200 cars with one locomotive every single day, it stops being impressive. It becomes routine, expected, normal. And when something becomes normal, people start asking, couldn't we do this cheaper? That's when the diesel salesman came calling, and the N&W management, despite their loyalty to steam, had to listen. Because the world was changing and the Y6, perfect as it was for its specific job, was about to become history. The end of the Y6 story is coming, but first, if you're enjoying this deep dive into railroad history, hit that like button. And drop a comment telling me which railroad you want covered next. Your engagement helps channels like this survive. Now let's talk about the end of an era. The irony of the Norfolk and Western's commitment to steam was that it was built on perfectly sound economics, until suddenly it wasn't. In 1955, the N&W's steam locomotives were newer, more efficient, and more reliable than most diesels. The Y6b locomotives, the final refinement of the design, were being built as late as 1952. That's 3 years after Baldwin built the last steam locomotive for any other American railroad. The N&W was still constructing state-of-the-art steam power when other railroads were cutting up their steamers for scrap. The railroad's management could point to hard data. Their steam fleet cost less to maintain than their competitors' diesels. Their locomotives burned the very commodity they hauled. Coal the railroad basically got at cost. Their Roanoke shops could build and rebuild steam locomotives with incredible efficiency. Every calculation said steam made sense, but they were calculating based on a world that was rapidly vanishing. The coal market was changing, steel mills were closing, home heating was switching from coal to oil and gas. And most critically, the pool of skilled steam locomotive engineers, firemen, and maintenance workers was aging out. Young men weren't learning to fire a locomotive when they could learn to drive a diesel and work in a clean, air-conditioned cab. In April 1958, a new president took over, Stuart T. Saunders. He looked at the numbers, different numbers than his predecessors had considered, and he made a decision that broke the hearts of railroaders across the system: full dieselization, immediately. The purge was swift and brutal. Locomotives that had 20 years of life left in them were lined up in the Roanoke yards, their fires dropped for the last time. The Y6 locomotives, these machines that could pull 200 cars, that had been built as recently as 6 years earlier, were suddenly obsolete. By July 1959, a special excursion was run, the Farewell to Steam. Y6b Locomotive 2174 hauled part of the route, pulling passenger cars instead of coal hoppers. Thousands of people lined the tracks to watch. They understood they were witnessing the end of something that would never come again. On May 6, 1960, Y6b No. 2190 pulled out of Williamson, West Virginia on the final steam-powered revenue run on the Norfolk and Western. The last 200-car coal train hauled by a single steam locomotive had already rolled into history, unremarked and unmourned except by the crews who ran them. Of the 81 Y6 class locomotives built, only 2 survived scrapping. Number 2156, a Y6A, was preserved, and eventually went to the Virginia Museum of Transportation. Number 2174, the locomotive from the farewell excursion, sat in a scrapyard for years. Local preservationists tried to save it but couldn't raise the money in time. In February 1976, the cutter's torches did their work. One of the most powerful steam locomotives ever built was reduced to scrap steel. The rest, 79 locomotives capable of pulling 200 cars, were cut up and melted down. Their steel probably became car parts, appliances, or rebar in office buildings. Machines that had moved millions of tons of coal, that had won a world war, that had done things people thought impossible, ended up as anonymous metal in anonymous products. Sometimes progress doesn't feel like progress. Here's what we lost when the Y6 locomotives were scrapped. We lost the institutional knowledge of how to move massive amounts of freight with brutal efficiency. Modern diesel locomotives are more versatile, cleaner, easier to operate. You can put a computer in a diesel, you can run them in multiple unit consists without a human being in every cab. You can operate them in below freezing weather without worrying about boilers freezing. Nobody is arguing we should go back to steam. But the Y6 represented something diesel technology still struggles to match: the ability to move enormous tonnages at low speeds up steep grades without overheating. A modern diesel develops maximum horsepower at 15 to 20 miles per hour. The Y6 developed maximum power starting from dead stop. For mountain railroading, this was ideal. And there's something else we lost: the culture of mechanical mastery that steam railroading demanded. A diesel locomotive is a machine you operate. A steam locomotive is a machine you partner with. Engineers who ran Y6 locomotives could hear a bearing going bad from the sound of the valve gear. Firemen could read the color of the smoke and know exactly what the fire needed. This was human-machine integration at a level we rarely see today. The story of the locomotive that pulled 200 cars is ultimately a story about purpose-built excellence. The Y6 wasn't trying to be everything to everyone. It had one job: move enormous amounts of coal from the mountains to the sea, regardless of weather, grade, or difficulty. And it did that job better than any machine before or since. In today's world of general-purpose solutions and flexible platforms, there's something quietly magnificent about a machine designed to do one thing perfectly. The Y6 was 600,000 pounds of steel and steam that said, "Give me 200 cars and get out of my way." It's been 65 years since the last one pulled a train. The coal piers at Lambert's Point have been rebuilt. The routes the Y6 locomotives ran are now travelled by modern diesels that can barely pull 100 cars over the same grades. The engineers and firemen who knew these machines have all passed away. The institutional knowledge is gone. But here's what remains: the documented proof that American engineers and workers once built something so good at its job that we've never quite equaled it since. The Y6 could move 20,000 tons with one locomotive. Today's railroads move similar tonnages, but they use multiple diesels, distributed power, and computer controls to do what a 1940s crew of two could do with coal, water, and skill. That's not nostalgia talking. That's just math. Sometimes the old ways weren't worse. Sometimes they were just different. And sometimes they were better than what came after. The locomotive that pulled 200 cars stands as proof that progress isn't always linear, and that obsolescence doesn't always mean inferiority. The Y6 locomotives are gone. But their memory challenges us to ask, what are we building today that future generations will look at and wonder how we lost the knowledge to create? What expertise are we letting slip away in the name of efficiency? Those are questions worth pondering, preferably while imagining the sound of 170,000 pounds of tractive effort, moving mountains of coal, one 200-car train at a time. If this story of forgotten engineering excellence hit you the way it hit me, do me a favor, share this video. Railroad history like this doesn't get told often enough. Subscribe if you want more deep dives into machines that changed the world. And drop a comment. Seriously, I read every single one. What other lost technologies should we remember? Thanks for watching. Until next time.